Hello students, welcome back to Narayana Digital Classes. Today we will be solving the assignment number 22 on the topic atomic structure. Let's move on to the assignment. Here the first question, the radiation having maximum wavelength is. So the maximum wavelength of a wave. So they have given four options. First one is UV rays, second one is gamma rays, and third one X-rays, and fourth one radio waves. Among these four, which one has the highest wavelength, the maximum wavelength? So according to electromagnetic radiation, electromagnetic spectrum, the radio waves have the maximum wavelength, which is around 1 meter. Which is around 1 meter, the wavelength of the radio waves. Wavelength of the radio waves is maximum wavelength, that is 1 meter. So here the correct option is the fourth option. The maximum wavelength is radio waves. Clear? Let's move to the next question. Here the second question, the radiation having least wavelength is. So according to electromagnetic spectrum, the spectrum will have the range 10 power, the wavelength range is 10 power minus 14 centimeters to 1 meter. So this 10 power minus 14 centimeter is the least radiation of a particular wave. So they have given four options. Among the four options, one of the rays has the lesser wavelength, right? So that least wavelength of a radiation is cosmic rays. That is first option. So cosmic rays generally have the least wavelength of the radiation, that is that wavelength is 10 power minus 14 centimeters. Right? Clear? Let's move on to the next question. Here the third question. Frequency of radiation with wavelength 480 nanometers. So here we need to find the frequency of a particular radiation. Frequency of a radiation. So frequency generally indicate with nu. We know that nu equal to C by lambda. Nu equal to C by lambda. Nu is the frequency we need to find, and lambda is wavelength. How much wavelength they have given? That is 480 nanometers. 480 nanometers. Which is equal to 480 into 10 power minus 7 centimeters. We know that 1 nanometer equal to 10 power minus 7 centimeter. So 480 nanometers equal to 480 into 10 power minus 7 centimeters. And C is the speed of light, which is 3 into 10 power 10 centimeter per second. Centimeter per second. Now substitute these values in the above formula. This frequency formula, we will get the frequency. So nu equal to C by lambda. C is 3 into 10 power 10 centimeter per second whole by, what is the lambda value? Lambda value is 480 into 10 power minus 7 centimeters. Clear? So this is, so centimeter will cancel. So 3 by 4.8 into 10 power 10 by 10 power minus 5. So if you solve this one, you will get 6.25 into 10 power 14 second inverse. 6.25 into 10 power 14 second inverse. So what is the correct option? The correct option is the third option. So this is the frequency of a particular radiation, which has the wavelength around 480 nanometers. Clear? Let's move on to the next problem. Here the fourth question, the frequency of wave light is 1 into 10 power 6 second inverse. The wavelength for this wave is, right? So they have given frequency. We need to find the wavelength. Frequency is how much? Frequency is 1 into 10 power 6 second inverse. We need to find the wavelength, that is lambda. We know that frequency nu equal to c by lambda. So nu is how much? 1 into 10 power 6 second inverse. And c is speed of light. It is 3 into 10 power 10 centimeter per second. We need to find the wavelength, that is lambda. So substitute these values in this formula. So nu equal to c by lambda, then lambda equal to c by nu, which is equal to 3 into 10 power 10 centimeter per second, whole by, what is the nu value? Nu value equal to 1 into 10 power 6 second inverse. So second inverse, second will cancel this, then lambda equal to 3 into 10 power 4 centimeters. So this is the wavelength of a radiation which has the frequency is 1 into 10 power 6 second inverse. So which one is the correct option? The correct option is first option. Clear? Let's move on to the next question. Here the fifth question. If lambda 1 and lambda 2 are the wavelength of X-rays and gamma rays, wavelength of X-rays and gamma rays respectively, the relation between them. So X-rays wavelength is lambda 1 and next one is gamma rays. So gamma rays wavelength is lambda 2, right? So according to electromagnetic spectrum, gamma rays has less wavelength than X-rays. According to electromagnetic spectrum, gamma rays has less wavelength than X-rays. Then we can write a relation lambda 1 greater than lambda 2. Lambda 1 greater than lambda 2. So the wavelength of the X-rays is more than the gamma rays. Right? So the correct option is the third option. Clear? Let's move on to the next question. Here the question is, which of the following is a correct? They have given few relations. So among these relations, which one is the correct option? Right? So first we know that nu equal to c by lambda. The frequency nu equal to speed of light by wavelength of a wave. So this is a correct statement, we know. So if you observe this statement, nu is always inversely proportional to the lambda. Nu is always inversely proportional to the lambda. Then we can write nu equal to 1 by lambda. Right? If you rearrange this equation, lambda equal to c by nu. Lambda equal to c by nu. Right? So first one is nu equal to c by lambda. The first option is also correct. Right? Second one is nu always inversely proportional to the wavelength. So nu equal to 1 by lambda. The second answer correct. And if you see the third option, lambda equal to c by nu. This is also correct. So the correct option is the fourth option. Clear? So with this, I come to the end of the session. Thank you very much.